In this first concept check question, you're asked to draw the products of the reaction shown. Let's start by surveying our reaction conditions. The leaving group is bromide. We have a tertiary alkyl halide, a protic solvent, and a weak base, water. These conditions all favor the carbocation intermediate, or an E1 pathway. In an E1 pathway, the leaving group leaves to form the carbocation. Then the base deprotonates the hydrogen. The base will deprotonate the hydrogen that will give rise to the more substituted alkene product. And here that's the internal hydrogen drawn in blue. This gives rise to the tri-substituted alkene. In this concept check question, you're asked about the conformations of the cyclohexane ring shown as it relates to an E2 elimination. So remember that there is a geometrical requirement for an E2 elimination that the hydrogen and the leaving group must be in an anti-paraplanar orientation. So if we look at the two different chair conformations shown here, we see that in only one is that geometrical requirement fulfilled, the one on the left. So an E2 reaction will only proceed from the conformation on the left. And more generally, for an E2 reaction to proceed from a cyclohexane ring, the hydrogen and the leaving group must be able to adopt a trans-diaxial conformation. That conformation will put the leaving group and the hydrogen in the necessary anti-paraplanar orientation. In this final question, we're again asked to predict the products that will result from the reaction shown. Again, I'll start by surveying the reaction conditions. Here we have a primary alkyl halide, and right away that should signal to me that a substitution reaction may be favored instead of an elimination. I also have a strong nucleophile, the methoxide, and a polar aprotic solvent. All of these conditions favor an SN2 substitution pathway. So here the reaction product will not be an alkene at all, but will be the methyl ether instead, the substitution product.